Right, so in this lesson, Chapter 1, Section 2, we're talking about order of operations and evaluating expressions. So more review. So first things first, powers. So if we, for example, have 3 to the 5th, this whole thing is considered the power. And at some point, I'll remember not to push down as hard. This whole thing is considered the power. The 5 in this example is our exponent, and then the 3 is our base. And so one way to remember it is that the base holds up the exponent, and all together they create the power, because there's power in numbers, power in working together. So power is the whole thing. The 5 is the exponent, which is being held up by the 3, which is the base. So how do we simplify the expression? Well, when we have 10 to the 7th power, that is the same as 10 times itself 7 times, because an exponent represents repeated multiplication. 6 and 7. And so then we evaluate. So 10 times itself 7 times. Three, 4, 5, 6, 7. All right. Is 10 million. And you can type that into the calculator. Most calculators, it's a button that looks like it has that little symbol right there. In programming, we call it the caret key. And so for this one, you would type in 10, little caret key, 7, and then that's what we will, and that will give you this answer here. All right. So 2/3 to the 3rd power, again, it's 2/3 times 2/3 times 2/3, but because we're noun for 1, we can also think of this, and we'll get into this in another section, but when we look at this, 2 times 2 times 2, that's the same as 2 cubed over 3 cubed, because it's 3 times 3 times 3. And so when we do that, 2 cubed is 8, and 3 cubed is 27, and so that's our final answer. Now, you can do what we did here, the 2/3 times 2/3 times 2/3. It works all the same way. All right, so then we have order of operations. We're going to perform operations inside our grouping symbols first. So parentheses, brackets, square brackets, curly brackets. The big one that we tend to forget is that fraction bar. And then after we do what is inside our grouping symbols, then we will move on to exponents and evaluate our exponents like we did in the last 2 examples. After evaluating exponents, we will multiply and divide. Pointing this out, multiplication and division are equal. So they just come, whatever comes first from left to right, and it's the same with addition and subtraction. Adding and subtracting is equal, so they happen from left to right. So what is the simplified form of the expression? So we find, here's our grouping symbols, so that's where we're going to start. We're going to start by taking 6 minus 2, and we get 4. So we get 4, I'm going to rewrite everything else, 4 cubed divided by 2. And from here, after grouping is exponents, and so I see that I have this 3 in my exponent, so I'm going to do the 4 to the 3rd power, which will give us 64. Rewrite the divide by 2. And then 64 divided by 2 is 32. And that's our answer. And so in this example, we have a grouping symbol. It's that fraction bar. So that's a grouping symbol on this problem here, once it'll let me. And what that means is I will take care of everything in the numerator that needs to be taken care of, and if there's multiple things in the denominator, take care of them before we worry about the division, and the division will be the last step. And so we're going to take 2 to the 4th, which is 16, minus 1, and divide by 5. And so then our next step is just take 16 minus 1, and we get 15, helps if I can do my math today, divided by 5, which will give us 3. And so our final answer is 3. So again, even though division is said to happen before adding or subtracting, because it's a fraction bar, it's being used as a grouping symbol, and they're not using parentheses. Alright, real quick. Vocabulary, we're going to be using substitution, which is replacing a variable with what the variable equals, and we're going to evaluate, which is simplifying an algebraic expression. And in order to do that, we first substitute. And then second, we will simplify using order of operations. So, example 4, what is the value of the expression for x equals 5 and y equals 2? So the first thing I'm going to do, and I guess what I forgot to mention is when we replace and use substitution, always put them in parentheses. Always, because you don't want to drop a negative anywhere. So I'm going to substitute for every x that I see 5 and for every y that I see a 2. So we're going to have 5 squared plus 5 minus 12 over 2 squared. Now once I have this, then I'm just going to evaluate by, or simplify using order of operations. So our grouping symbol, again, we've got this fraction bar. I know we have sets of parentheses. There's only a number. It's not grouping anything together. Our grouping symbol is the fraction bar. So I'm going to come up to the top, and in my numerator, I have an exponent. So 5 squared is 25. We have plus 5 minus 12. And I'm going to do the exponent, evaluate the exponent in the bottom. So 2 squared is 4. From here, I still have to simplify the numerator, so I'm going to take 25 plus 5, which is 30, and then 30 minus 12 is 28. Let me double check that math. Silly me, I knew that didn't seem right. It's 18. I forgot to borrow my 1 when I did that mentally. So we have 18 over 4. From here, we're just going to simplify. 2 goes into both, so we end up with 9 over 2. So 9 halves. I know in the past you've been told to make it a mixed number unless Math Excel tells you to. I would prefer it to just be improper. So we just leave it as 9 halves. Alright, our next example, what is the value of the expression for x equals 5 and y equals 2? So again, I'm going to plug in for what I have. So we have 5 times 2, all of that, squared, over 5 times 2. So we're going to work with our grouping symbol. So on the numerator, we're going to go inside the parentheses and do 5 times 2, which is 10. And that's going to end up being squared over 5 times 2, which is 10. So 10 squared is 100, and 100 divided by 10 gives us 10. And that is our final answer. And then this was the activity we did in class that day. So that is order of operations and evaluating expressions. Until next time.